Hello everyone, this is lecture 5 and this lecture is about the recovery and purification of fermentation products. Well, the good news is already most part of this lecture we already have been discussed in lecture 1. Okay, so in this part, I will skip, I will not discuss about those part which has already been discussed in lecture 1 in this uh, lecture. Okay, and I will tell you that which slides have been already discussed. Okay, well, so let's start. So just for the recap, so we already know that total fermentation process, it can be divided into three parts: the upstream process, the main fermenter or main fermentation, and the downstream process. Okay, so what we do in the downstream processing? Okay, what kind of works we do? So this kind of works: harvest the cell, disrupt the cell, product concentration. We actually do this. We concentrate the product during recovery of the product. Okay, then product purification from cell extracts of the growth media, and then packaging and transport. Okay, and the product recovery stage of the fermentation process, it's sometimes complex process, and it can be sometimes quite difficult and costly. Okay, so usually the recovery cost may vary from 15% to 20% of the total production cost. Okay, and the recovery process, we can separate it in different stages. That means that total recovery process, it has different stages. Okay, so in the first stage, what is done, that after the fermentation is finished, we separate the solid and the liquid part. Okay, so here it is written like removal of solids. It's actually mean first we need to separate the liquid and the solid. Okay, so now if our product is an extracellular product, then it will be in the liquid portion. Okay, so then we'll deal with the liquid portion. But if the product is in the solid part, that means in the cells, then we'll harvest the cell and we need to disrupt the cell. Okay, so then, so whatever the now the product can be in the this cell disruption, or the product can be in the liquid, so whatever it is, so then we need to isolate the product. If the product is in the liquid, then we have to isolate the product from the liquid. So if the product is in the disrupted cell, then we have to isolate the product. Okay, and there are different methods for doing this. Okay, and then once we get the isolated product, okay, then we need to purify them and concentrate them. Okay, and then we will do the final touch. Okay, to make the final product. Okay, so these are the stages of the product recovery of a fermentation process. Okay, so in and these different stages, there are different methods that we can use. So in this lecture we'll talk about this. Okay, so however, going to those methods first, as I said, there are different methods, that means different recovery process to recover the product. So which process or methods we'll use, it depends on several factors, such as whether the product is a intercellular or extracellular product. Okay, and the concentration of the product in the fermentation broth, that means how much product is there, the physical and chemical properties of the desired product. Okay, so these are actually important, because in say for example, there are some methods, physical methods, in which these methods the force exert is kind of high. So if our final product is physically weak, okay, so in that case we cannot use those kind of harsh conditions. Okay, so what is the physical and chemical properties of our product, it's also important. Okay, so based on that we will choose the process that we use to recover the product. Okay, so then the intended use of the product, for what purpose we are going to use that product. If we are going to use that product as, like, say for example, a therapeutic agent to treat a disease, then it have to be very pure. Okay, so so intended use is also important. Okay, because sometimes we may not need the very pure form of the product. Okay? So then the minimum acceptable standard of purity, the magnitude of biohazard of the product or the broth, the impurities in the fermented broth, the marketable price for the product. Okay, so we have to consider all these factors in choosing of the recovery process. Okay, well, I mean sometimes, for after fermentation, recovery, product recovery is poor. Okay, it can happen because of like contamination or depending on some other factors. The recovery process can be poor. Okay, that means the yield will be poor, or there will be many impurities or contamination in the purified product. Okay, however, there are ways to improve this. Okay, so how we can improve the product recovery? By doing these things, like selection of a microorganism which does not produce pigments or undesirable metabolites. So if our fermenter organism, okay, if our organism produce too much pigments or undesirable metabolites, so it will be difficult to purify our product. Okay, then modification of the fermentation to reduce the production of undesirable metabolites, precise timing of harvesting. Okay, and pH control after harvesting, temperature treatment after harvesting, addition of flocculating agents, use of enzymes to attack the cell loss. I mean, okay, so there are different ways by which we can improve the product recovery. Okay, so it doesn't mean that in for the same process we will use all these things. Okay, so sometimes we may just need, like say, if we just can use a better strain, that is a better microorganism, maybe our product will be more pure. That means if we can select a microorganisms which don't produce undesirable metabolites or too much unwanted pigments, okay, then maybe the recovery will be easier. Okay, so in that case maybe we don't need to do the other improvement procedures. Okay, but or sometimes we may apply multiple improvement processes to improve the product recovery. Okay, so it depends. It will depend on the product and the process. Okay, so now we'll start with the methods by which we uh, harvest our product and then purify. Okay, so first, say the fermentation is done. Now the fermentation is complete. So, okay, so our product may be extracellular. If it is extracellular, it will be in the liquid. If it is a intracellular, it will be in the solid part. Okay, so whatever our product is, extracellular or intracellular, the first step after the fermentation is done is we have to separate the solid and the liquid portion. Okay, so how we can do that? There are different methods like high speed centrifugation, high speed semi continuous centrifugation, membrane and membrane microfiltration. Okay, so these methods have already been discussed in lecture 1. Okay, so that's why I will skip these slides, until slide number 22. So this we have already discussed. So from slide number 8 to slide 22. Okay, so in this slide, the process by which we separate the uh, liquid from the solid portion, and then after separation, if our product is a intracellular, then how we disrupt the cell. So this methods has been discussed up to slide number 22, and this we have already learned in lecture 1. So that's why I am skipping this. Okay, so now we have separated the solid portion and liquid portion. Okay, so now say if okay, so now say that our product is in the liquid portion. Okay, so if our product is in the liquid portion, what we need to do? We have to extract that product. We have to do liquid extraction, right? Because our product is in the liquid. Okay, so how we can do that? Okay, how we can do the liquid extraction? Okay, so there are different methods of doing that, like for example solvent recovery, chromatography by using membranes. Okay, so now I'll talk about those. Okay, so first, using solvent recovery. Okay, so The process of solvent recovery is, say our product is in the liquid, so we need to add a chemical which will, where our desired product will be dissolved. Okay, so solvent recovery means we'll add such a chemical there that our desired product will get into that solvent. Okay, so first we'll add the solvent, our product will get into that solvent, then we have to separate this solvent from the rest of the liquid. Okay, and this is usually this can be done by distillation process. Okay, and the distillation process may be achieved in three stages. So first, evaporation, so the removal of solvent as a vapor from the solution. Then the vapor liquid separation in a column is done to separate the lower boiling more volatile component from other less volatile components. Okay, a fractional distillation, okay, it is sometimes called. So if we, in distillation process, what we do, actually heat, and we know that different chemicals, they have different boiling temperature. Okay, so different product, they get evaporated in different temperatures. So based on these characteristics, they can be separated in a column. Okay, and then finally, when we we collect our desired vapor portion, then we condensate it and we get our product. Okay, that means we get our product in the solvent. Okay, so it was about a solvent recovery. Then another method of liquid extraction, or or we can say the product extraction, chromatography. Okay, so chromatography techniques, these are, okay, I'll say these are kind of sophisticated techniques. Okay, and chromatography methods are very good to make the product very pure. Okay, so chromatography techniques are used to isolate and purify relatively low concentration of metabolic products. Chromatography methods are costly. Okay, so if we have to use the chromatographic method, those are costly methods. So that's why, I mean, always we don't use the chromatographic method. Like, although it's very good to make the product very pure, but still, as it is costly, so basically we use it when, like, say, the our product, that means the metabolic products, its concentration is very low in the fermentation solution. In that case, we use the chromatography. Or say we need a very pure product, okay, in that case we can choose the chromatography. Okay, and the by chromatographic methods, the separation of the solutes can be, we can separate the solutes based on different characteristics of the product, like, say, based on the charge, polarity, size, and affinity of the products. Okay, so that means the chromatographic methods separate solutes based on their charge, polarity, size, and affinity. Okay, and there are different chromatographic methods, so depending on our purpose, we will choose which chromatographic methods we are going to use. So these are the name of those different chromatographic methods, such as adsorption chromatography, ion exchange chromatography, gel uh, permeation chromatography, affinity chromatography, reverse phase chromatography, HPLC. Okay, so so in this lecture, I'm not going to discuss in very details about these processes. Okay, so I guess many of you already are familiar with this process, because you maybe already learned about this process in different courses. However, so this lecture has been prepared solely from the Principle of Fermentation Technology book, written by Stanberry, third edition. Okay, so I'll suggest you to check that book. I already have uploaded this book in the box, right? So please check that book. Okay, so you will get a more clear idea about this methods. Okay, you will find more details about these methods there. Okay, we learned about the solvent recovery and chromatography. Then another method, membrane process. So by the name we can guess that in this method, membranes are used which have semi permeability. Okay, so all the membrane has semi permeability, because membranes have define pore size. So they will let the products which is less than its pore size to go through, and the product which size is more than the pore size, they will capture those product. Okay, so that means in membrane process the products are separated based on their size. Okay, or the molecules are separated based on their sizes. Okay, and there are different ways or process to do the membrane processes. So say ultrafiltration and reverse osmosis. Okay, these two are different process, but both of them they follow the membrane process mechanism. Okay, so in case of ultrafiltration, solutes of high molecular weight are retained when the solvent and the low molecular weight solutes are forced under the hydraulic pressure through a membrane of a very fine pore size, typically between 0.001 and 0.1 micrometer. These are very small pore actually. Okay, so it is therefore used for product concentration and purification. Well, the basic is same. I mean, in case of ultrafiltration, why we are calling it ultrafiltration? There are different kind of membranes. Okay, some membranes their pore size are kind of big, but in this case, the membranes which are used, their pore size is very small. Okay, they have ultra pore size. That's why it is called ultrafiltration, because we can separate very small size molecules. Okay, how small? 0.001, even 0.001 micrometers is very small. That's why it is called ultrafiltration. Okay, so by using the ultrafiltration we can both purify product and also we can concentrate the product. Okay, say for example the product size is say for example your product size is 0.05 micrometer. Okay, 0.05 micrometer. So now if you use a filter which pore size is 0.04, so what will happen? After filtration your product will be top of the filter, right? And all the molecules which are less than your product size will go through the filter. That means you will get a concentrated product. Okay, it will be kind of be a concentrated product. Also we can use the ultrafiltration to purify our products, like even like from bacteria and viruses. Okay, and this kind of the filters, the ultra filters, they are made from a variety of polymeric materials, and they have different pore size. Okay, with different molecular weight cutoffs. Okay, molecular weight cutoffs is a measurement of like measurement about the pore size of the filter and the retention capability. Okay. Okay, and we can use ultrafiltration to separate macromolecules such as proteins, enzymes, hormones, viruses. Okay, these are very smaller. Bacteria is kind of, I mean, size of bacteria is bigger if we compare their size with this. Okay, proteins, enzymes, hormones, viruses, they are very small. So we can use ultrafiltration to separate this. I mean, if we just need to separate bacteria, okay, we actually don't need the ultrafilter. Okay, because well, I mean, definitely by using ultrafiltration we can separate the bacteria, but we will not use that because ultrafiltration they are more costly than the regular for filter. Okay, so if we want to separate the bacteria, we just can use the normal filter, or even you can just separate bacteria by centrifugation. Okay, so it was ultrafiltration, then reverse osmosis, another membrane process, reverse osmosis. Okay. Okay, so reverse osmosis, it is sometimes also called hyperfiltration. Okay, so in this case also semi-permeable membranes are used. So then why we call it reverse osmosis? Because in this case the solvent molecules that we want to separate, so we force the solvent molecules to flow through a semi-permeable membrane in the opposite direction to that directed by osmotic forces. Okay, so I mean we force the solvent to flow through opposite direction of osmotic forces. Okay, so I mean normally it will not occur. Okay, normally the solvent will not flow in the opposite direction dictated by osmotic pressures forces. Okay, so we do this, we achieve this by applying pressure. Okay, so that's why it is called reverse osmosis process. Okay, and where we use reverse osmosis. Okay, so the we can say the efficiency of reverse osmosis is more than the ultrafiltration. Okay, so like if the product size is so small that we cannot separate them by ultrafiltration, then we choose reverse osmosis process. Okay, and there is another version of reverse osmosis, nanofiltration. Okay, and in nanofiltration it utilizes charged membranes to separate small solutes and charged species based on both charge and size effects. I mean, in case of reverse osmosis or the ultrafiltration, basically we just separate the molecules get separated by their size. But in case of nanofiltration, which is a modified version of reverse osmosis, the molecules get separated both based on the size and the charge. Okay, okay, so these were the uh, liquid liquid separation process. So now, so like you already separate your product. Okay, so now what we need to do, we need to do the final touch to make our final product. Okay, so based on our like goal, I mean in what form we want our products or what's our intended use of the product, we may use different methods. Okay, say for example there are different way, like we can dry the product, or we can form we can get our product in crystal form. Okay, okay, so usually, drying of any product is often the last stage of a manufacturing process. Okay, and it involves the final removal of water from a heat-sensitive material. Okay, and drying. I mean, if we can dry the product, it has some benefits, like the cost of transport will be reduced. Okay, so it's definitely. I mean, if it is not dry, it has water content in it, it will be heavier. Okay, and also then we have to use, like, the transportation cost will be more. Okay, and also like transporting dry materials is much easier than transporting a moistured product. Okay, and the material will be easy to handle and package, and the material can be stored more conveniently in a dry state. Okay, it's always easy to store dry things than the wet things. Okay, wet things always has more chances to get contamination. Okay, okay, then crystallization. Okay, so sometimes the product, the product, crystal of the product are formed. Okay, like for example different organic acid or amino acids. Okay, they are purified as crystal form. Okay, so for example in citric acid production, the filtered broth is treated with calcium hydroxide so that the relatively insoluble calcium citrate crystals will be precipitated from the solution. Okay, so we have the, I mean, our product is in the now crystal form, so you can just easily separate those from the solution. Okay, okay, so well now the whole broth processing. Okay, whole broth processing is I mean, so far we have discussed, I mean, how we can separate the solid from the liquid. I mean, after the, I mean, when the fermentation is done, how we separate the solid from the liquid, and how we separate the, if our product is in the liquid, then how we separate the liquid, how we do the, how we do the liquid liquid separation. Okay, so how we can do the purification and the okay, so whole broth processing is it's a different approach than those. Okay, so the approach of whole broth processing is like that we will directly, I mean, after the fermentation is done, we will directly separate our product from that fermented liquid. Okay, so this is the goal of whole broth processing. Okay, so if we can do that, I mean, if we can directly harvest or purify or recover our product from the fermented, I mean from the fermented liquid, definitely it will be better, cause because it will lower the cost, and also we don't have to do many complicated, many tedious processes like the cell harvesting and the purification, separation. Okay, we don't have to do those kind of things. Okay, so that means the product purification will be much simple, and the cost will be low. Okay, and if we can do that, if we can do the whole growth processing, then also will be able to uh, recover our product continuously. Okay, so like, say for example, you are doing your fermentation in a continuous process. So in continuous process, we continuously harvest our product. We continuously harvest the fermented product. Okay, so in that case, if we can do the whole growth processing, that means if we can directly separate the purify the product from the from there, it will be easier, right? The fermentation will go continuously, and will be able to continuously purify or recover our product. Okay, okay, so that was all for this lecture. And as I already said, this lecture, you will find everything of this lecture in chapter 10 of this book, Principles of Fermentation Technology, Stanbury. Okay, the third edition. So I will suggest that please also check that chapter. Okay, so you will find very details methods that we have discussed here. Okay, okay, thank you for your patience.